Welcome to episode 9 of the GEA Performance Podcast. There's so much conversation out there at the moment, and confusion, and probably excitement, and definitely fear, around artificial intelligence, ChatGPT, and what is the future of AI. So I decided to speak to somebody who's leading the way in this field on a global level in terms of AI in sport. Patrick Lucey is the Chief Data Scientist and lead of the AI team at Stats Perform, who provide performance analysis and data for hundreds of teams across different sports, including PSG, Bayern Munich, Premier League teams, the All Blacks, NBA teams such as the Golden State Warriors. He talks to us about how they're currently using AI to help these teams, about ghosting and tracking and Optivision, and what's the future of AI in sport. I also ask him how far off are sports like the GEA from incorporating AI at team performance level and also for the media analysis. And just to get us started and as a bit of a taster, here's Patrick talking at a conference about some really cool ways that Stats Perform use AI to help teams.
For the longest period of time, we've been using words. Words just don't cut it. And so it's a paradigm shift in how we query. Instead of using words, we want to use the visual modality. 40 to 50% of our brain is associated with the visual cortex. Let's get that to work. And let's just say I play a game. And what you're going to see is the tracking data. So I just pick a game of interest. I say, and I can just get it streaming. Again, red is the ball, yellow is going left to right, and green is going right to left. And so I can get the human to select how long the play is, so just say it's a 3-second play, and I could scrub through to find what is interesting, or it could be streaming live. And so imagine if I get to a point in the game, I go, well, stop. Find me all the plays like that. I click a button, in less than a second, I can give you a ranked list of all the plays like that. But this is inherently interactive. This is interpretable. So imagine if I could say, well, I'm only interested in a couple of those plays in the ball. Find me all the plays like that. And then I have a refined list there. Or I have an iPad, or I have some type of interactive device. Why can't I draw a player and query that? That's what we can do now, okay? What I get really excited, I think that's cool, but what I get really excited about is the idea of what if. So imagine if I had this play, I could say, well, stop. Tell me everything about that. What's the likelihood of this player scoring that position? What happens if I move that player around? What happens if I move that defender around? How does that change the percentage? Or what happens if I switch that player with another player? How does that change? So it's the interface to enable us to ask the questions that we really want. And now machine learning, interactive interface, we can start to do this.
Thanks so much, Patrick, for your time. You might give us a bit of an intro into your own background and what you're doing with Stats Perform and Stats Perform itself.
Yeah, sure. Well, thanks for having me, Eamon. So, I'll just give an introduction to Stats Perform. So, if you watch a soccer game and interested in the score and you put that into Google, if you've ever thought where that sports data comes from, that comes from us. If you ask Amazon Alexa or Apple Siri any sports information, we'll provide that data to them. Most teams around the world use our data, especially with soccer and also sports books. So, the data that pops up on the app, they get that from us. So wherever sports is being played, we provide that data. And I'm chief scientist here at Stats Perform. I've been with the company for close to 8 years. I set up the group 8 years ago. And to do anything interesting in AI, you need the data. So a lot of the data collection that we do is via humans. So we've been around for 40 plus years, but we've also been pioneers in computer vision. So in terms of player and ball tracking, in 2010, we had our SportView solution where we were in 4 NBA arenas. And then in 2013, we were in all NBA arenas. So we really pioneered play and ball tracking. So when we talk about AI, that's a part of AI called computer vision, where we have cameras and at 25 frames per second, we're able to locate where the players and the ball are. We do that extensively for soccer. But there's been a big paradigm shift where we can actually do it from any video now, where we can get player tracking data. And maybe we can talk about that a bit later around our Optivision, which is coming out very, very soon. So that's one element. You need data to do anything interesting in AI, but using machine learning, we can actually use the raw data on top to come up with metrics come up with predictions, and we can get a better understanding of performance. So if anyone has seen the movie Moneyball, I read the book. The idea there is to use data to make better decisions in sport. You can think about using deeper data from AI, such as the player tracking data, and using machine learning on top, really is Moneyball version 2.0, where we can just make better decisions from more granular data. So at a very high level, that's what the company does. That's what I do. My background's in computer vision and machine learning. I have a PhD in that. I left Australia with my PhD 14 years ago, moved to the US, worked at Carnegie Mellon University at the Robotics Institute, worked at Disney Research, working on an automatic sports broadcast. But I came to Stats Perform to set up the group because, again, as I said, to do anything interesting in AI, you need the data. And at Stats Perform, we have the deepest treasure troves of data out there.
And I suppose the kind of your B2B, so you're essentially working with a kind of media broadcast. You're saying Google and you're also working, I'd imagine, with like betting companies and then teams as well.
Correct. So anywhere, call it the sports ecosystem. So for media and broadcast, so if you watch the Sky sports broadcast, they use Opta. Opta is our data brand. That's us. Teams use our Opta data, whether it's understanding performance or making recruitment decisions, and also sports books, especially in soccer. You see that data being adjudicated on, they get their data from us, but also the video, the watch and bet video stream or a bet video stream, we provide that too. But we are B2B, so people at home probably haven't heard of us, but if you consume sports data in any one of those verticals, it's more likely than not that comes from us.
Yeah, I suppose the kind of main interest for us today is the team analysis side of it, and you work with a range of sports. I suppose soccer is kind of probably the biggest sport in the world, and something which of the global sports I suppose can be kind of linked in terms of the run of play towards GAA that we have here, and obviously there's a lot of soccer played here as well. So if you could give us kind of a bit of an insight into I suppose the ways that AI is used. I know that there's a bit of confusion with, I suppose anything kind of techie or analysis or data these days is considered AI, but like in terms of, like you were talking about the data collection, how a lot of it is still done by humans, but computer vision, I suppose, maybe giving a bit of an insight into that as well, because that's essentially moving away from that, isn't it?
Yeah. So, first of all, I think it's useful to get definitions of AI and the value of data. So first of all, I'd like to define what sports data and the value that it has. So the way that I see it is that sports data really reconstructs the story of the match or performance, and the more granular the data that you have, the better reconstruction that you can have. Now, to make use of that data, it can get very granular. So as I mentioned, we use artificial intelligence to collect some of that data. And the way that I define artificial intelligence is to getting technology to emulate a human at a specific task. And whether it is understanding where a player is on the field, that's a very, very good task of that. So that's what we call data generation. And then once you have that raw data, you need to have some type of understanding. Can we understand performance, whether it's at the team level or an individual player? And so that's where machine learning, which is under AI, where instead of getting rules, we get a human to understand the rules from data. That's where we use machine learning to understand performance. So a really good example in soccer is something called expected goal value. I'm sure in GAA has you have an equivalent metric as well. But essentially the idea is that it's not just getting shots, it is the quality of the shot. And there's a lot of context around that, such as, the location of the shot. What were the previous actions? Where's the goalkeeper location? Where are the defenders? Was the shot with the left or right foot? All those different factors. So you consider, we have 35, 39 different features that go into that. You need basically machine learning to compress all that information into one number. So we really use that as a thermometer to quantitatively or objectively measure performance. And that's really the value there, because it's one thing having data, but once you have lots of different fields, you need some type of mechanism to compress it and again, use it as a thermometer to just get a value there, so you can start comparing performance and understanding performance through that way.
I suppose with the GA here, kind of wouldn't be as advanced in terms of data analysis as in other sports. Would actually probably be a long way off of it. But one of the main components, I suppose, that most of the listeners here would associate with data analysis would be, I suppose, the graphic that you would get at the end of the game, giving you, your kickouts won, lost, possessions, just kind of the basic raw breakdown, which obviously takes a massive amount of time and man hours. But I suppose that computer vision technology is one of the things which essentially will be able to give you something like that within a couple of seconds, I imagine, straight after the game or even at half time.
Yeah, potentially. So a lot of those metrics that you mentioned are predominantly done by humans, and there's something to be said by getting that perception, understanding like the context, understanding when the referee blows his or her whistle, understanding that. So you can get human generated data, but where computer vision comes into it is that you can potentially automatically do those things, and we do that, but it is starting to detect tactical aspects or starting to value possession. So it's one thing to say, well, this team had X number of possessions or X or Y number of shots. The idea is, well, that's just a number. It lacks a bit of context. So can we get a bit more information to say, well, were they good decisions? Was that a worthwhile shot? In terms of the possessions, was the possession via a counterattack, or was it just what type of possession it was? Those types of things. So just say you do it, Eamon, you start coding it and I start coding it. We can come up with different definitions. So the nice thing about using computer vision machine learning is that we can get an expert, and that same definition can be applied across all games. So you don't have that variability there. And that's really a value with using computer vision machine learning to kind of get scale, but also get the same reliable, uniform definitions of those metrics that you just mentioned.
I suppose kind of some of the stuff though, such as like possession in terms of counting the possession for a team, or number of possessions for a player, or a number of shots on target, or a number of shots on target within a certain zone. That's kind of very, factual, like, as opposed to the other stuff is going to depend on like somebody's idea of quality possession, and not quality possession is kind of, again, is very subjective. So I suppose in terms of the AI side of things, I suppose it's when you're thinking about it, like a lot of analysts, maybe looking at AI, like probably most people in the world, and thinking, is it going to take my job? Whereas it definitely is going to be able to replace the side of just sheer factual data collection. But I suppose the side of breaking down subjective decisions on like what is quality, like the modeling, essentially, that is probably going to make data analysts more important than ever.
Yeah, so I see AI not as replacing experts. It is really to help them. It is our goal is to build assistive technology to help decision makers and analysts make better decisions. You raised a really good example there. There's a lot of subjectivity. Depends on the mood. It depends on experience of people. So really, the first thing with using machine learning in sports is to replace a lot of that subjectivity. Is to come up with these KPIs which are objective, and instead of using rules, we can actually learn what the best metrics are, from a data-driven approach. So that's really the first element there. The second element, which is around like automatic event tagging, you still need to have a human in the loop. I think a really good example is thinking outside of sport with autonomous vehicles. People have this the holy grail is to have full autonomy, but really the sweet spot is to build technology to help drivers. And that's what we're finding. You always need a driver, or you'll always need a pilot in a plane. We're just helping with the telemetry. We're building technology just to make things more efficient, getting better measurements. So that's a way that you can think about artificial intelligence in sport. And obviously, with ChatGPT coming out, that is seen as a great assistive tool. That's learnt on natural language, like all the text data in the world. But sports isn't text data. It's actually its own language, and at Stats Perform, we're creating our own type of technology where we can do those type of things specifically for sport.
So you're using the data that you collate to find out what the KPIs are essentially, and then with those KPIs, then you're getting more data then essentially, so that the KPIs aren't subjective, they're based on the initial data.
Yes. Yes. So, and raise the example of Moneyball. It is, coming up with letting data really be data and using AI on top to come up with these intelligent data points, which really tell the story and give a measure of performance. But that's just one input. And I think you raised that point before, Eamon. You still need experts. There are a lot of things that we don't capture. There are a lot of these soft skills where coaches and analysts will understand, the different personalities of players. A player could have had a fight with their significant other, or the kids didn't sleep the night before. We don't digitize that. That's performed with the keeper of public record. But this is where we can provide those inputs to coaches and analysts. But there are other inputs, stuff that happens on the training ground, private data, medical data that we won't have. So this is where the experts can start to piece together and have a bit more certainty with making decisions. But it's really assistive because a lot of ways they don't do that. So using us and the technology that we generate, it should help their lives, should help in their decision making as well.
I suppose we're kind of, computer learning, or would you be able to give us a couple of examples maybe of how teams are using it, I suppose, tactically? So it was described to me by somebody working in the field that there's technology now being used that can essentially, it can create, you can input different attacking scenarios, and then based off of a data storage of like numerous game plays of defensive plays of an opposition, you can kind of essentially put in an input of an attack and play, and the computer learning will give you the most likely scenario of how that defense will respond. Like, could you give us an example of that? Or?
Yeah, absolutely. So we pioneered this technology 4 or 5 years ago. So there's a couple of things that you can do. So the technology that you mentioned is something called ghosting, where you have a play. We'll just use soccer as an example. So just say you had Manchester City playing against Arsenal, and we had the tracking data of that game. And then you could say, well, we have the tracking data and the dots are moving around. And so you could ask the question, well, if I'm an analyst for Arsenal, you could say, well, how should have that team defended? How could we have defended to minimize the expected goal value? Or how should have we defended that play to minimize the likelihood of this team getting a good shot? And so using our historical data, we can actually simulate what that team should have done to minimize that expected goal value. So that's one element there. Another thing that we can do is really measure things that couldn't be measured before. As we know in soccer, formation or shape is the language of the game. It's hidden, we understand it, but that's how we communicate. But how do we actually measure those things? So we actually pioneered that technology too, where we can measure if a team's playing a 4-4-2, which role each player is, how often they overlap, or when a team has changed shape. Can we detect when they went to from a 4-4-2 to a 4-3-3? So previously, teams would spend, hundreds of hours detecting that from a game, just manually doing that. And now we can do that within a second using this automatic technology. Also, analyzing each action. We talked about expected goal value with shots, but can we start to analyze each pass? Did the player make the right pass? What was the likelihood of a player making that pass in that situation? Or should have that player pass to the other players? And we have this technology, this telemetry within our Optivision output, where we can just get that granular analysis of each action and each play where you couldn't measure before. And so I think that also highlights the value of AI. We can start to measure things that you just couldn't measure before.
I suppose with that, so when it's giving you your what should have been the right pass, or that ghosting in general, it's based off of the simulations are created off of having a massive reservoir of like just loads of games with that team or a team who plays in a similar way, essentially, and then it goes off of patterns of previous. But is there involved in even that kind of simulation? Is there still someone who kind of is defining what would be the best pass, or is it just literally the computer is deciding, this is where the space was, or this is what normally leads to goals?
Yes. So it's very much a ladder there. So again, humans have their biases, they're subjective. So essentially what we're able to do is link it to an overall reward function, such as, next 10 seconds. Historically, this has led to a shot, given all this different contextual, or given the context that happened beforehand. So that's how we do it in an objective way.
Yeah. So, and then I suppose you could, with different teams, some teams might have different expectations or different outcomes that they want, and then you would obviously then just be able to tailor that just through the modeling of it. Is that something that happens with teams?
Yes, so each team has their own language. Each team has their own KPIs or style of play. And so not everyone's going to play like Manchester City. Some other teams will just sit back and play counter-attack or counter-pressing type of game. So that's where you need to condition the analysis based on the style that is what the team is after or the coach is after. And so this is very much where you need the expert in the loop, really to define what were they going for, what are the KPIs which are relevant or important to the team, and optimize for those set of goals instead of just applying general goals, which isn't really applicable and is not going to work in practice. So as we've talked about previously, having that domain knowledge, understanding that style and really constraining it so you can just limit it based on those KPIs is really the best way of approaching this.
And that ghosting technology, it's used in soccer. Is it used in other sports? And is that kind of the nucleus of most of the stuff that you're doing with team analysis?
So we've done that for basketball as well, but it is really much a function of the availability of tracking data, and this is why we're excited about Optivision, where we can get tracking data from every game of soccer that's being played. But there's a lot that you can do without tracking data. So with the Opta event data, essentially we capture that for all games of soccer. And so we can come up, and that's very powerful too, because it essentially is giving information about all the on-ball events. And so that's very important because you think about the global nature of soccer, where you have that data for every game, you can start coming up with the same KPIs for every team or every player around the world. So if you think about recruitment, bringing in a player, just say from Ireland into the English system, or bringing a player from the US or Australia, where I'm from, to another club, you need that uniformity of data. You need those uniformity of metrics so you can start comparing apples to apples. So in terms of AI, it's important to have the coverage or the scale where you have that data coverage and then applying those metrics. And then, having the depth is also important as well. But it really depends on the application. So for recruitment, you need to cover all the games being played with the same uniformity of data so you can have those same metrics there.
Yeah, and I suppose for GA, that's essentially the big challenge, because what we don't have in GA is a centralized, I suppose, database of games. And we don't have a centralized database of even just general data collection. So you're kind of looking at each county and each team has their own reservoir, but trying to get it all together, and then there'll be missing links. So I suppose that would be the biggest challenge for a start for bringing AI into GA, or the use of AI into GA, and is essentially the first thing you need to do is create a massive reservoir of data.
It is having that massive reservoir, but it has to be uniform. So it has to, and people don't talk about it, but companies like us are central to that Moneyball revolution, where you need that uniformity in operations to collect that data at scale. And so, teams can start comparing apples to apples. Otherwise, it's very, very difficult.
I suppose in terms of if you were to bring the basketball, the movement of basketball in terms of there's no offside and the movement inside and the cutting, that's very similar to, I suppose, to the gameplay of GA. It's just that we're a much bigger field and a lot more players. But I suppose the same thing, just to try and kind of give a visual, or for listeners who are thinking in their mind of how the ghosting would apply, or how it's applied in basketball. So for instance, if the point guard had the ball, started an attack and it would and gave a pass that didn't work, or there was no score off of it, it would essentially be able to tell you, what would have been the better option there, is it? And then defensively, likewise, it would tell you, what might have been the best shape to approach, or.
Yeah, so potentially, each sport, again, we talk about language, and if your listeners have heard about ChatGPT and large language models, there is the language, natural language, which these models are trained on. Now, each sport has their own language. So, if you talk about GAA, it has their own language or grammar. So, first of all, you need to have that constraint. Like, what are the rules of the game? Possession. So, what is the terminology associated with that? What are the different roles? And so, once you have that information, once you have that depth of data, and with the ghosting technology, it's really about learning from observation. So if you had enough observation and context, you could start having that as an input, and then you could start asking the question, what should have we done in that situation? And so that's how we've approached it for basketball and soccer. It's really constrained to the nuances of the game. Soccer is continuous. It still has possession. Basketball it's the same. It has possessions, but it's more segmented because there's a lot more shots.
I suppose with the KPIs, essentially, that they're, in a way, you're essentially rating or listing from like 1 to whatever in terms of what is the most important outcome, and then kind of that's how the computer learns. Like, who essentially then, so when you're putting together these models and you have your data scientists and your AI experts such as yourself, and is it each team then? Is it someone in their data analyst team, or is there somebody who's essentially saying this for us is 1, 2, 3, 4, 5? Like, how does it essentially work with the top teams in terms of, is there a lot of collaboration with all of this, or?
Yeah, so that's a really good question. So each team is different, and strategy is really the intellectual property of the teams, like their tactics. That is hidden. What's important to them. So it depends on the teams that you work with. Some teams, they want to keep it secret. Some teams and partners want to, collaborate with you. So, we don't really disclose who does what, and along those lines. But it's, as I mentioned before, we're the keeper of public records. So, when matches are being played, we have that uniformity of data. We have those uniformity of metrics. So, first of all, getting that trust and the reliability of that information, then they can start using it in their processes, whether it's match analysis, whether it's recruitment, whether it is anything along those lines. And if they need assistance, of course, we help. But essentially, it all starts with just having the raw data or the intelligent data on top, where they can come up with those KPIs. And those KPIs could vary from team to team, but also match to match, depending on who they're playing.
Yeah, but I suppose what I mean in terms of, is there like traditional like coaches and managers who are coming to you saying, this is what I want you to focus on? Is there like, a Premier League head coach or manager who's literally sitting down and saying like, this is the most important thing, or is it all kind of a generic idea of what's the most important thing?
It's a bit of both. Some teams are just interested in one thing, like counterattack. So if that's their KPI, they're only interested in that, and so that's the number that they will look at. But other teams, they have other things like set plays. What are we doing set play? How do they defend? And I'm using soccer as an example here. So really, our goal is basically to measure these things, count these things, and you really can't improve what you can't measure. So once we have these measurements, then it's up for the domain experts. And hopefully, we talk about language and vocabulary. Hopefully, the vocabulary that we've captured can measure everything that's important within a game. And then each coach can pick the KPI. Again, for counterattacks, it may be that's the only thing that we're interested in. Our performance is going to be based on counterattacks, how players perform within that. our efficiency around that. And then from that measure, you can look at efficiency, effectiveness, offensive and defensive. There's a lot you can do with that one number. But other teams may look at lots of different numbers and break it down, or certain players for certain numbers. So hopefully I'm not giving you a non-answer there, but it's really about, getting those measurements in place, again, the thermometers in place where people can start, understanding performance and making certain tweaks. And, it could be the certain KPIs that they have aren't effective and they need more information or more granular information. And that's definitely when they come back with us and say, well, we need a bit more there. And that's how we work with partners, to continually evolve and come up with better measurements and qualifiers on top of that.
Yeah, because I suppose like what could be generally considered as fairly basic. In GA, like you have, like in any sport, you have tackling, and then you have a pass, and what could be considered as a progressive pass, and then what is considered as a tackle. So in GA, like some people might consider a tackle actual making contact, or another person might consider a tackle, I suppose, initiating a reaction from the opposition player. And then that really depends on subjective kind of opinions. And then likewise, a progressive pass, like a progressive pass could be, does it need to be forward? Does it need to be of a certain distance? Like it kind of, that stuff becomes very much. So that's why I'm always kind of thinking with this is that obviously, I suppose the more input you can kind of get in the initial level between what somebody actually wants or what they consider.
Yeah. And again, it's around definitions. I understand the point you're getting to. Like what I think is, like a progressive pass, and you think is a progressive pass, or a different coach is going to be different. So how do you get consensus there? And the answer is most of the time we get consensus, but sometimes people want their own metrics. And that's, you find in other sports, they'll have their own team and kind of adding to the foundation that we have. And they say, well, I want something more granular there. I want something more specific, which is important to me. And so they'll either talk to us, see if we can do it, or they'll actually do it themselves and really augment the foundation that we build. But again, it's consensus, and a lot of the times we can measure things better than what humans can do anyway. Or it's adding qualifiers on top of it. It could be, well, this is a progressive pass, but there's certain elements to that. It's not just yes or no. There could be certain intensities or probability of that occurring, which can get around some of those issues, because some people have different settings. So you can have that where they can have dials where they can switch things on and off, or have it higher or lower than others.
Yeah. I suppose a lot of what you're doing is kind of building towards the future, I suppose, essentially, because you're essentially setting what the future is going to look like in what you're working on now. And I suppose, but for something like the GA, we're probably looking at what you're doing now as our future. So it's kind of a funny enough one, but
there's a lot of examples there. It's no point reinventing the wheel. And, I think what we're doing is just digitizing the game. As an expert in GAA, you understand the game. So how can we get a computer to see that game and really digitize it? Because otherwise we're just watching raw pixels. And so that's really the idea with sports analytics. So how can we basically digitize it, where you can search it, where you can query it, where you can do analysis? And that's really the role of sports analytics, and using AI can help us automate that, collect different data, and then on top of it, we can do recommendations, we can make predictions. There's a lot that you can do, but you need that uniformity of data and that language on top, and then there's so much you can do from that.
In terms of recruitment, because I suppose in GA it's a slightly different one in terms of our recruitment is it's not a fully professional game. So like obviously like soccer or these games, so we don't have we're not buying players in, but there is a county tier and there is a club tier. So you're selecting from the club players. Like how does that work in terms of, is it essentially the same technology and the results that or the answers that you get with it, then you create a database of players, or is there a different type of technology you use for player recruitment?
So you still use that same reservoir of data. And again, it depends on the sport. So soccer is a global sport. You have different leagues across the world, but for each team, they have different KPIs. So it could be age, it could be the style of play, it could be budget, and then you just need to be able to tune to that. If you look in basketball, we do a lot of work with basketball where we use our AutoStats technology, and we've collected over 10,000 games of tracking data of college basketball, but also international basketball. So the goal there is to, again, provide uniform data where we can start to compare players and get that same data that we have in the NBA. I suppose for GAA, it's basically one league. I know there's a bit of interchange between Aussie rules football in Australia, where I'm from, and GAA. I think in Australia, AFL is professional, and they'll bring a couple of the Irish players who've been very successful there, and looking at those attributes there. So I think looking at in-match performance is one thing, but there are other things, qualitative or soft skills, such as personality. There's fitness data, there is medical data. And again, you have to be able to get those measurements of the player, and that's private. So in terms of match data, we can do a really good job there, but that's just one part of the puzzle. There is other important information. If the player is very young, what's their growth profile? It could be 16, but they're 5'8". They get to 17, then they're 6'4". So how do we know their growth profile? Like, they're growing into their body, like in terms of skill acquisition. I know in American football, they'll look at personality tests. They'll look at all those risks there. So again, in-match performance is one of those things, but in terms of recruitment, it really depends on, a whole myriad of things. And it's just where you can get measurements. And a lot of those things you may not be able to measure as well.
I recall reading about Liverpool when they bought Naby Keita and how that he, topped their charts in terms of, I think it was carries or possessions, breaking defensive line in a certain scenario, or so essentially you would have the same thing. You would find the language that, and the KPIs that you consider to be the most important for recruitment, and you put them in, and it's gonna give you the list of performances.
So we have all that data, we have all those data points, and it's basically enabling the decision makers. Once they have that, they say, well, these KPIs are important to our team. Which player has those characteristics? Maybe saying, well, we're only looking at the top tier leagues. We're only looking at players of a certain age. And just recommend all the players there, because it's not suggesting which player should you get. It's really a list of players that you should look at, and then there are other elements there too you should look at, like medical history and all those things. So it's a very effective recommendation list, approaching it that way.
What's the use of it in AFL that you're seeing at the moment, kind of in terms of match specific? Is there anything very interesting that you're seeing in AFL analysis for AI?
Yeah, so in terms of stats perform, we don't do much with Australian rules football. From Australia, I know a bit about AFL, but yeah, I don't know too much detail what's done at a day-to-day, but I'd imagine it's very similar to what we do in soccer and basketball. We do stuff in rugby league as well, but just, again, it would be understanding, performance, what we talked about, getting the KPIs, and then just seeing which players rank high in those attributes. But again, given AFL, which is similar to GAA, there's a lot of physical demands on the player. And so how do you get, how often they're injured, or again, there's a lot of that private medical information that would be taken into consideration.
I suppose just kind of a final kind of question on the future of AI. Like what do you see as like a potential for, down the line, like the absolute, potential or the dream kind of things that you're working on, and what you see can be done?
Yeah, so I think there's two things that pop to mind. The first thing is to basically collect tracking data of every game that's been played, men's and women's. So we have our Optivision product or a project that we're looking at. That's our goal. Every game of football that's been played, we want to have the same level of data, granular tracking data, not only for men's but also the women's game, and hopefully that scales downwards as well. Because again, you need that uniformity of data, which I've mentioned a couple of times. But then the ability to scale to all games, right? So again, the big power of AI is scale, and being able to enable these types of things, this analysis to occur. But I think the second thing is really around interacting and the interacting with this technology. And I think ChatGPT has enabled that, being able to ask a question in natural language. So these models should not just be available to coders or data scientists. You should be able to ask a question in the language that you have very simply and get an answer. And so I think making this technology and these data points accessible by this by these really nice interfaces and easy to use in an easy to use interactive way is really promising, because again, first of all, having access to large amounts of data at scale across all formats, but then also being able to interact with that data in an easy way where you don't necessarily have to be a coder or a data scientist, I think are the two most exciting things.
How far off do you think we are from having that kind of availability of AI technology from, say, like given a GA level, I suppose college level sports, or I suppose maybe semi-professional sports, before it becomes something that's kind of readily available?
Yeah, so that's a very good question. So from a stats perform point of view, our focus is on professional sport and doing this across soccer. So that's really our goal. I think it really, I think the technology isn't far away from doing that. It's just around the logistics and getting buy-in from the different leagues. There are different things to consider there, so it's not so straightforward. And just getting the buy-in from the various teams. So scaling it across different sports. Again, each sport is different. Getting that human in the loop, understanding the rules, it takes time. It's not just what we have for soccer we can blindly apply to GAA. There's that kind of onboarding, understanding that, and looking at the edge cases. So and making sure the technology can work in a reliable and scalable fashion.
Yeah. That's really, really interesting. Like I do think it's something that so many people, because of it's just on everyone's minds, AI now, especially the last couple of months more than ever, and it is just so interesting how it's being used already. But yeah, it's been like this. I suppose you've been doing this work for a couple of years now, but it's just
yeah, I've been doing this for over 15 years, and AI has been used for the last 15 years. I do think just with the emergence of these technologies, it's on people's radar, and a lot of the data points that you see, especially in the soccer broadcast, they've been around. Like XG's been around for 10 years. We've updated it with XG2, but you have momentum, you have possession value in soccer, you have a lot of these metrics, which we've been working on for a very long time, and now get it out and people responding and interacting with it, which is very exciting.
Yeah. Well, I won't hold you any longer. I know you're busy over there in Chicago, but thanks so much for your time and for teaching us. And we're really excited to see what the future for AI is. Thanks, Patrick.
No problem. Thanks, Simon.